By the way, so we're now on our third week. So for today, so we will go with the last topic for the basic method. Okay, so in solving linear program problems. So just to recall from the previous meetings, so we discussed the different methods in solving a linear program problems. So we started with the graphical method. Okay, so just to show the feasible region, so for us to determine the optimum points. Okay, so whether that is a maximum or minimum. However, that is a graphical solution. But then there are uh, analytical solutions. Okay, so in solving an LP problem. Okay, so the first one is we introduce the simplex method for maximization. So that method is particularly useful whenever the constraints involves a less than or equal to, okay, relation. If all of the constraints are less than or equal to, except of course for the non-negative constraints, then we are going to use the simplex method for maximization. And of course, the question or the objective is a maximization problem. And then again, so for those constraints, so we are just introducing um, uh, the S1, okay, and the S2, or the slack variables. And then for problems, so whether that is a maximization problem or a minimization problem, but it involves a combination of less than two or equal to, and at the same time a greater than or an equal to. If it is a combination, then we use the big M method. So the big M method not only uses the slack variables, so it also introduces the artificial variable and the uh, surplus variable. Okay. So for every greater than or equal to constraints, so we introduce an artificial variable, so together with a surplus variable. Okay, so that's the difference of the big M method. So lastly, what we did not cover yet would be what if it is a minimization problem, but it involves purely a greater than or equal to. Okay, so if it's a minimization problem, but it involves all of the constraints are greater than or equal to, and then the problem is a minimization problem, then we are going to use the simplex method for minimization problem. Okay, so in short, simplex method it's used whenever the constraints are less than 2 or equal, or whenever the constraints are greater than 2 or equal. Okay, so if it is a less than 2 or equal and the problem is minimization, we use simplex method. So if the constraints are greater than 2 or equal, and the problem is about minimization, then we use as well the minimization problem. But if it is a combination of less than 2 and equal, or greater than 2 and equal, then that's the time that we use the big M method. So now, how do we use the simplex method, or what would be the algorithm? So for the simplex method for minimization problem. So these are the steps. So the first one, so we need to form the augmented matrix for the given system of inequalities for primal problem, including the objective function. So we solve it. Okay. So just like or we formulate, okay, so the linear program, so similar with the linear program that we are doing before. But this time, so since the simplex method is actually intended for less than or equal to constraints, so we have to transform those constraints from greater than to less than. Okay? So we are going to change the inequalities from greater than to or equal into less than or equal. So how do we do that? So we can do that one, so by transposing. Okay, so the given matrix. Okay, so once we form the augmented matrix, so we're going to transform. Okay, so we're going to transform the matrix, uh, transpose the matrix. So the purpose of that is to transform the greater than 2 or equal sign for the constraints into less than 2 or equal. So once we were able to transpose it, I'm not sure if if you know what I'm talking about, but if you had an advanced mathematics in the undergrad, okay, and then you deal with matrices. So I'm referring to the transposition. So the transposition is the process of changing the columns into rows and then changing the rows into columns. Okay. So by doing that, okay, so we are transforming. Okay, so we are the transforming the inequalities. Okay, so from a greater than or equal to into a less than or equal to. Kasi the simplex method is intended for less than to or equal to na constraints. Okay, so after doing the transposition, we were now able to transform it into less than to or equal to. And then after that, so we're going to form the dual maximization problem. So this time, so yung objective function natin before, okay, so dun sa primal problem natin, so we're going to change it into a dual maximization problem. Okay? Uh, so most of the time, let's say for example, if we have a 3 by 2 matrix, okay, so if we have a 3 by 2 matrix, so after the transposition, we're going to transform, okay, the size from a 3 by 2 to 2 by 3. Okay, so thus, na the constraints reduces. Okay, so from 3 it will become 2. And then afterwards, so once we were able to form the dual maximization problem, so again, we formed the tableau. So similar with the simplex method. And then we solve it. So the same method in solving a simplex method problem. Okay, so those are the 4 steps in the minimization problem. So using the simplex method. Steps in solving. Okay, so the basic values of x sub 1, x sub 2, and x sub n on the zero of the final simplex tableau in the columns corresponding to the slack variables. So once we solve the tableau and then we were able to eliminate already all the negative coefficient on our objective function in the last tableau, then we can find our solution. Okay, so we can find our solution based on the entries for the slack variables under the objective function row. Okay, so hindi siya kamukha nung sa simplex method, the typical simplex method. So the typical simplex method before, so we find the values. Okay, so we find the optimal values based on the solution doon sa slack variable rows natin. Pero for the minimization problem, so we find the solution doon sa objective function row natin. Objective function row, and then look at the slack variables column. Then that would be our solution. So to better understand that one, so let's have this problem. So it says that okay, so it's not a worded problem. So we want to understand the mathematics behind it. So again, so our objective is to minimize the cost. So to minimize the cost, so we are given the objective function of 6x plus 8y. And then we are given constraints that 40x plus 10y should be greater than or equal to 2,400. So 10x plus 15y should be greater than or equal to 2,100. And 5x plus 15y should be equal to 1,500. Okay, so our objective is to minimize the cost. So what would be that cost and how many for the value of x, or how much for the value of x and for the value of y. So to solve for this one, uh, I can do so the Excel na lang. Hmm. for the primal problem. I'm just going to introduce the objective function and of course the constraints. So for our objective function, so it's 6x plus 8y. So 6x plus 8y. And for our first constraint, so we have 40x plus 10y. So 40x plus 10y should be greater than or equal to 2,400. Second is 10x 15y. So 10x plus 15y should be greater than or equal to 2,100. And 5 and 15y. So 5x plus 15y should be greater than or equal to 1,500. So 5x plus 15y is greater than or equal to 1,500. Okay. So the next one is we're going to form our matrix here. So that is, so we have for the column, so we have the variable x and the variable y, and then we have the solution. So before we transpose, so we write, so we start with, okay, so I'll start with the objective function. So I'll just have, so we get the coefficient. So we have a 6 and 8, and then a 0 for the solution part. So for the first constraint, so we have 40, and then so 10 and 2,400. So we have a 10 for the second constraint, so 15 and 2,100. And then for the last constraint, so we have 5, 15, and 1,500. Okay, so that will be our regional table. And what we're going to do is we're going to transpose this one. Okay. So para ma-transpose siya, so you just click the paste here. Meron tayong transpose dito. Saglit. Parang nagbaligtad. Anyway, I'll start with the the constraints instead of the so para nandun sa dulo yung solution natin. So I'm just going to copy this one. So I'll highlight this one, and then I'm going to paste it on one cell, transpose it. Okay. So what can we notice this time? Uh, so after the transposition, so make sure that we started with the constraints, and then so remember that this is our first constraint. Then we have our second constraint. And then we have our third constraint. And we have our z function. So after that, so look at this one. So we have three constraints. Uh, and then after the transposition method, so we're going to have two constraints only. So first constraint, the second constraint, and of course we have the z function. So ayan, we're going to introduce a new variable. So we change the x and y. Okay. So this time, so instead of two variables, we have three. So I'm going to introduce a u, a v, and a w. And this will become our solution. So after transposition, so this will be our table. No? So for our primal problem, so ayan siya. No? Color code na. And then, so we have the transposition, and then we change it to the dual problem. No? So we transform it back into this one. So yung objective at saka yung constraints natin. So yung objective natin, so kukuhanin natin siya dun sa transpose table natin. So z this time will be equal to 2,400 u plus 2,100 v and then plus 1,500 w. And then for our constraints, so for the first constraint, so we have the 40 u plus 10 v plus 5 w. So this time, so yung kanina, so since we transpose it already, so as you can see here, the 40x plus 10y is greater than or equal to. So this time around, so this one will become less than or equal to 6 since we already transpose it. Okay, so we change the greater than or equal to relation into a less than to or equal. And then we have the 10 u plus 15 v and 15 or plus 15 w is less than or equal to 8. Ano nga ba siya? 10, 10, 15, 15. Okay. So once you are done, so we can now form our first blue. Okay? So para dun sa first blue natin, so we have the Z, and then so we have a U, a V for the variables, and then a W. Then we have two constraints. So therefore we have two slack variables. And then we have the solution. And of course we have the intercept. So we have three, so one objective function z, and then we have the first constraints. So for the first constraint, so that correspond to the slack variable s1 and then the slack variable s2 for the second constraint. Okay. So now we fill out the first tableau. So for our first tableau, so z function, so z is 1. Then we have negative 2, 4 for u. So negative 2, 1 for v, and then negative 1, 5 for w. So we don't have slack variable, so 0, 0. Solution is 0 as well. And then for S1, so we have 0 for Z, so 40 for U, and then 10 for V, and then 5 for W. So we have S1, so since that's the first constraint, so 0 for S2, and then 6 for the solution. So for our S2, so we have 10, or sorry, 0, so for Z, and then U is 10, so 15 for V, 15, and then 15 as well for W. So 0 for S1, 1 for S2, and then 8 for the solution. Okay, so this is now our first tableau. Okay, so for our first tableau, so we follow the same procedure for the simplex method. So the entering variable so corresponds to the least negative. So we have three negatives here, the negative 2, 4, negative 2, 1, and negative 1, 5. So as we can see here, so the variable u so corresponds to the least negative. Okay, so among the three variables. And then, so since that is the least negative column, so we solve for the intercept. So that's the solution. So we divide it with the coefficient. Okay, so for that row. So making it 0.15 and zero point 0.8. And as we've mentioned before, so the living variable so corresponds to the least positive. Okay, so we have 0.15 and zero point 0.8. So therefore, the least positive is 0.15. So giving us that the S1 row so becomes our living variable row. So making 40 as our uh, pivot point. So 40 is our pivot point. Our objective, of course, is to, so for uh, the second tableau, so by the way, so S2 is our living variable, so therefore it should become U. And then, so since this would be our pivot row or pivot point, so we need to change this one into 1. Okay, so the 40 should be 1. So therefore, we divide the entire or the second row by 40. So doing that, so that will be equal to, so R2, so we divide it by 40. And then, so we just copy it, okay, so until the end. So we have, okay, so the 40 becomes 1. Uh, and then for our first row, so we want to zero out the negative 2, 4, okay, and the positive 10, okay. So the element above 40 and the element about above 10, okay, so should become 0. So to do that, so we're going to uh, take the entire row, so the first row, and then we minus it by negative 2, 4. So that becomes positive 2,400. multiplying it with the pivot row. So pivot row is the second row. So similarly, so we can show that so to make 10, okay, so equivalent to 0, so we take the third row and then so we subtract 10, then multiply it with the pivot row, so which is the R2. So doing that, so R1, so this is our R1, and then so I'm going to take minus, no? Shortcut. Nalaman ko na yung shortcut sa akin. It is a MacBook. So it is Fn F4. So that's the shortcut. I'm not sure with the Windows. Uh, and then we multiply it with R2. So ang R2 natin is yung nasa second tableau. Then we can do that one as well for the third row. So third row, then we minus it. So this time with 10. So since that is fixed, so we make it $sign and then multiply it with our second row. Then we copy the entire thing till the end. Okay. So same as true with this one. So as you can see, so the negative 2, 4 becomes 0, and then the positive 10 becomes 0 as well. So the pivot column or the pivot element is still 0. And based on our second tableau, we still have two negative coefficient, the negative 1,500 and the negative 1,200. Negative 1,5 and the negative 1,2. But negative 1,5 is more negative. So therefore, the column V so will serve as our entering variable. So to determine our leaving variable, so we get the intercept. So that is the solution. So divide it with the element of our of the column. So where the living variable resides. It's 0.6. So the other one is 0.52. So as we can see here, so 0.52 is the less positive of the two intercept. Hence, our S2 column, okay, so becomes our the living variable. And then the 12.5 so becomes our uh, pivot point. And so for our tableau number 3, so we copy the entire table, clear it. Okay, so I'll start with this one. So my main objective here is to make the pivot element equivalent to 1. So to do that, I'm going to multiply the entire row or divide the entire row by 12.5. So doing that, so that will be equal to the third row. So divide it with 12.5. So the 12.5 should become 1. Okay, so there it is. So this one becomes 1. By the way, the S2, so since that is already the living variable, so it will be changed into V. And then, okay, so for our first column, so our objective is to zero out the negative 1,5 and the positive 0.25. So to do that, so we get the first row, sorry. So we have the first row, so row 1, then we subtract negative 1,5, so it becomes positive 1,5, so multiply it with our pivot row, so which is the R3. So similarly for the second row, R2, So it's 0.25, so minus 0.25, multiply it with R3. So doing that, so we have our R1 and then minus our pivot column. And then, so fixed it, so multiply it with R3. So R3, the succeeding table. And then, so for the second row, so that will be R2, then minus, so the 0.25, so fixed it, multiply it with the pivot row. Okay, so what can we see now? So we can see now that there are no longer negative coefficient on our z function or on our zero objective function row. Therefore, that is already the optimum tableau. And what I've mentioned before, so how are we going to determine? So the values, okay, so the values for x and y can be seen on the slack variable column. So in this case, yung S1 natin, so that corresponds to our basic variable x, and then yung y natin will be yung nandun sa tawag dito, sa S2. Okay, so slack variable S2. So therefore, x is actually equal to 30, and then y is equal to 120, and then the maximum solution so will be 1,140. Or sorry, minimum. Okay, so the minimum solution so would be 1,140. So we should produce 30 units of X and then 120 units of Y, and that will yield to a minimum cost of 1,140. So that's how we do it. So using the tableau form. Okay, so we can do this one as well using the Excel solver. So let's say I'll have an X and a Y here, and then I'm going to minimize C. So following the same problem, right? Okay, so we have an X, a Y, and minimum C. And then for the C, so we're using the Excel solver, so I just need to form the table first. Uh, then we produced our constraints. So we have the left hand side, the right hand side. So we're just going to do the constraints. So first, just copy sa taas. Okay. So for our minimum value for C, so that will be equal to 6. Multiply it with X, and then plus 8, multiply it with Y. And then for our left hand side, so that will be equal to 40, multiply it with X, then plus 10, multiply it with Y. It should be greater than or equal to 2,400. For our second constraint, so we have 10, so multiply it with X, then plus 15, multiply it with Y. It should be greater than or equal to 2,100. And lastly, so we have 5, multiply it with X, and then plus 15, multiply it with Y. Or, sorry, should be Y. And then greater than or equal to 1,500. So that's forming our table. So using Excel solver, so yung sa objective natin, so that will be the minimum C. Ulit. Galing ko yung pagka-maximize niya. Okay. So solver, disable yung ano ko. So let me close it. Wala. Wala siya. Anyway, Okay, copy ko na lang. Ito. So ito yung kaninang in-input. Pero ang sagot doon, I think, negative 30, 120, and 140. Uh, so if we do the solver, so we just input the objective. Then we click minimum. Changing variables should be x and y. And then for the constraints, so we add. So since pare-pares naman silang greater than or equal to, so I can select the 3 and then greater than or equal to, then the constraints would be, so select the 3 as well. So you click OK, and then so we use Simplex LP and we solve it. Ayun. So we have for the value of x to be 30, and then y is 120, and then 4 is 1140. So which is the same as what we were able to solve a while ago. So for the tableau, okay? Yun lang yung naging problema. Hindi ko na